All right. Um, what we're going to do today is a analysis of variance, and this is using a data set that I and Megan Crosby collected a while back. And what we're going to do is going to be very simple. We're going to be looking at three different conditions. A condition where individuals are given short-term exposure to a weapon, a short-term exposure to the same weapon with a strikeout, a circle and a strikeout around it to indicate warning against weapons, sort of a prohibited condition, and then, of course, a neutral condition, okay, where there's a neutral image like a flower. All right, so we have that, and we're going to see if the proportion of aggressive words completed is different depending upon these different conditions. And actually, what Megan and I tested very specifically was whether or not these, each of the weapons conditions would prime a higher proportion of aggressive words completed compared to the neutral condition. So we actually had some planned comparisons in mind, and I'll try to show you how to do that. So really, let's just dive right in. And I'm going to choose ANOVA because that'll be a little bit more, I think, versatile. I'm going to go ahead and get our estimate of effect size. We're going to go ahead and make sure that we get our assumptions checks taken care of. Homogeneity being the very important one, normality less so. Given that we have a sample over 30, I'm not going to worry about that. Contrasts, we'll get to in a moment. Estimated marginal means we're definitely going to want to get. And I don't want plots, I think I want tables. That seems to be pretty helpful. And then we'll just go ahead and start plugging in everything. You might remember that everything in ANOVA, from what you've read, we refer to the independent variable as a factor. And then proportion of aggressive words completed, or what we call here prop ag, that's just simply the dependent variable. And you'll start to see some information populated. You'll notice that when you look at the sums of squares for the condition and your residual sums of squares, your means you're between treatments and within treatments, you'll notice that those numbers are computed for you. You'll see that because we have three treatment conditions, k minus 1 will equal 2 degrees of freedom. Because we have 93 participants total, really the best thing we can do is say subtract really 3 from that, and you'll be fine there. Then it's just a matter of dividing the sums of squares by its respective degrees of freedom. That gives you your mean square, and this gives you your F ratio. And again, the question is, if these two were equivalent, then the F would be effectively 1. Then the question is, does this F get to be greater enough than 1 to where we can rule out the null hypothesis? And overall, it looks like there is some difference here among the means. The homogeneity of variances test ends up being just significant. We're very, very happy about that. And then we're going to go ahead and do our contrasts here, and we're going to go ahead and get a difference contrast. And what this will do for us is it'll say, hey, take a look at this. If we compare the weapon warning and weapon conditions, they're really not that different from each other. So that's about what we would expect. And more importantly, if you compare the neutral condition to the weapon and weapon warning conditions, check this out. Um, this turns out to be significant, which is what we would have predicted. So this is actually really good news here, and the sort of thing that um, for a preliminary study I enjoy seeing. Estimated marginal means, let's just go ahead and pop that in. And since I ordered a means table, what that'll do eventually is that'll go ahead and give us, once this has a chance to do its thing, an idea of what happens. Okay, about 19% of the words completed in the weapon condition were aggressive. And the weapon warning condition, or weapon prohibited condition, that becomes a little over 18.5%. So there's a little bit of a drop off, but not a whole bunch. And then when you look at the neutral condition, you can see that a little over 14.5% of the words completed were aggressive. Okay. There's some variability, but nothing too terribly awful, it looks like. So we're in pretty good shape. But that's essentially what we've got here. So you can see the summary table is all set up for you, just the way you'd set it up in a normal hand calculation run. We're able to very conveniently do the assumptions checks, and then we're able to, and even though normality was, this is clearly not a normal distribution at all. That's not a big deal for us. We're not going to worry about that. The big thing was homogeneity of variance, and we seem to be fortunate there. Contrasts, we're very happy with those. Certainly Megan and I were at the time. And then then you see the actual cell means here, and these all look very, very good. This gives you means and standard errors. Computing from standard error to standard deviation is not that hard. You can actually find those conversions online if you wanted to do so. And that is pretty much it. So on that note, we're going to go ahead and end this. Make sure to save your data set. And when you save it, make sure to upload the file, and you should be good to go.